This video is on the objective distinguish between use cases of the chi-square tests. Alright, so in this video we're going to see in what scenarios, under what kind of tests are we going to be using this chi-square distribution to help us perform the test. These are chi-square tests. And there were three of them in this, in our instruction here. Again, if you want to read more about it here, click on more instruction. And in fact, because I don't feel like writing all this out, I got it right here, what they're going to have in their instruction. So what are these use cases? When are we going to be using the chi-square distribution to perform hypothesis tests? So there are three major applications of the chi-square distribution. Number one, the goodness of fit test. This test determines if data fit a particular distribution. So like we may suspect that data fit a specific distribution, like a binomial distribution or a uniform distribution, for example. In either case, we can use a chi-square test, meaning that the distribution for the hypothesis test will be that chi-square distribution, to determine if there is a fit or not. It is typically used to see if the population is uniform, where all outcomes occur with equal frequency. The population is normal, or the population is the same as another population with a known distribution. Now, when you set up a test, remember every hypothesis test has hypotheses, a null hypothesis and an alternative hypothesis. So for the goodness of fit test, your null hypothesis, what you're going to be assuming to be true, and then decide whether or not to reject that later, it's going to be that the population fits the given distribution. All right, so you're going to be assuming that the population fits a uniform distribution, or that the population fits a normal distribution, or whatever you suspect it fits. And then the alternative hypothesis is simply the opposite of that, right? That the population does not fit the given distribution. Okay, so they have an example here of when you would use a goodness of fit test, set up these hypotheses, and work with the chi-square distribution. So their example, a study indicates that the number of televisions that American families a study indicates that the number of televisions that American families have fit a certain distribution, given in a table. Data from a random sample of 600 families in the far western United States was collected. Are the two distributions different? Right, so this would be considered a goodness, you'd be applying a goodness of fit test here. Do these number of televisions distribution, does it fit the distribution that they're suspecting it fits, right? Does the distribution from my sample fit the distribution I suspect? Right. The second scenario, second type of chi-square test we're going to be running, is a test of independence. So this test determines if two variables or two factors are independent or dependent. Are they not related in any way or related in some way? In this case, there will be two qualitative survey questions or experiments, and a contingency table will be constructed. And we'll see examples of contingency tables. You've seen them already back when we were talking about probability and conditional probability and all that. So you've seen contingency tables, it's just been a while. And again, when we run these tests to see if two variables are independent of one another, the null hypothesis, what we're going to be assuming to be true, and then deciding if we're going to reject that later or not, you're going to assume that the two variables or factors are independent. And then the alternative hypothesis will be that the two variables are not independent or are dependent. So this will always be our hypothesis setup. And then they go over an example here of when you would run a chi-square test of independence. So an example is a sample of 300 students is taken. Of the students surveyed, 50 were music students, while 250 were not. Of those total students, 97 were on the honor roll, while 203 were not. The question is being a music student independent of being on the honor roll? Okay, so do they have a relationship? Are you more likely to be on the honor roll or less likely if you're a music student, or is there just no relationship at all? Right? Are they totally independent? So this kind of a question, again, we'll be running a chi-square test of independence to determine if being a music student is a factor that is independent of being on the honor roll. All right, then the final scenario, the final kind of chi-square test we're going to be running is a test of homogeneity. All right, so earlier you saw the goodness of fit test. All right. The goodness of fit test can be used to decide whether a population fits a given distribution. All right, so I have this population with an unknown distribution, and then I want to see if it fits a uniform or fits a normal, fits something that I do know. But it will not suffice to decide whether the two populations will follow the same unknown distribution, right? What if both populations are unknown that I'm talking about? So that's where this comes in. Right? The test of homogeneity can be used to draw a conclusion about whether two populations have the same distribution. So again, I take like two samples, one sample, another sample, separate sample, and then I'm asking, are these two samples coming from populations that have the same distribution or not? That's this test for homogeneity. And again, they tell us what the hypotheses are going to be every single time here. The null hypothesis, what you're going to assume is that the distributions of the two populations are the same. They have the same distribution. And then the opposite of that, right, the alternative hypothesis is that the distributions are not the same. And then you'll run through, find a test statistic and all that, and we'll get to all that stuff in later videos, and then decide whether or not you want to reject the null hypothesis or not reject it, and so on. So here's an example of where you'd be running a test of homogeneity. Suppose that 250 randomly selected male college students and 300 randomly selected female college students were asked about their living arrangements, dormitory, apartment, with their parents, or other. Using the results, determine if male and female college students have the same distribution of living arrangements. All right, so do the male living arrangements have the same distribution as the female living arrangements? And this is a test for homogeneity where the chi-square distribution will come into play. Right. And again, some key terms, the different types of tests. Right. Again, hopefully you've seen the videos where I've gone over the introduction to the properties of a chi-square distribution. Okay, so I'm not going to get into that. Then they have some more problems and stuff. Okay, so let's get back to the question. So again, here, if you want, click on more instruction yourself. You'll basically see what I just read through you. In which of the following situations should the chi-square test for independence be used? So remember, this chi-square test for independence was to determine, if two variables or two factors are independent or dependent. All right. So let's read. Which one would I use a test for independence? So here, a political polling company puts out a survey asking people two questions. First, it asks for the person's political party, right, whether the person identifies as Republican, Democrat, or Independent. Second, It asks whether or not the person supports an upcoming environmental protection bill. The data are recorded in a contingency table. The company wants to determine if support for the bill depends on political party. Well, there's the key word right there. Depends. They're trying to determine here if political party and support for this bill are independent or not. These two factors, these two variables. So this is it right here. I don't have to read any further. Now I will read the other ones just to tell you which tests we'd use, right? Which of the three tests, the chi-squared tests we'll use. You'd use the chi-squared test for independence here. All right, and then your null hypothesis would be that they are independent, and your alternative hypothesis would be that they aren't independent or they are dependent. Look at this second choice. A dice manufacturer is trying to determine if their dice are fair. They test a die by rolling it many times and recording the distribution of the rolls. They want to compare this distribution with the uniform distribution. So, is the distribution of my dice rolls fitting a uniform distribution? So this test here would be a goodness of fit test. You'd perform a chi-square goodness of fit test. Does this distribution fit a uniform distribution, a known distribution? And again, your null hypothesis would be that they do fit, and the alternative would be that they don't. And then again, we'll get into how to run these tests later. And this third option, a researcher is trying to determine if salaries for men and women in the tech industry have the same distribution. Well, right there, that's a test for homogeneity. Right? Do the salaries of men and the salaries of women in this industry, do these two groups have the same distribution? Right? This would be a test for homogeneity. And the null hypothesis would be that they do have the same distribution. The alternative would be that they don't. And then you'd run your test. Yeah, so the only one that fits here, where you'd be running a test for independence, is this first one, right? Is political party and support for this bill, are these factors independent or not? And again, read through your answer explanations, make sure you understand what's going on. Alright, so hopefully listening to me here, watching me go over the instruction, going over the question, looking at more instruction on your own as well, reading this OpenStax book, looking at the answer explanations when they come up. I'm hoping all this stuff helps you out when you're going over the material on your own. All right, and thank you very much for watching.